Hello and welcome to GER Hub Mathematics and Statistics lessons. Today we shall be looking at the solver series on set theory part 1, okay? Where we shall be solving questions on set theory, and this will continue in other parts of our solver series videos on set theory. So let's begin. Now the first question here reads, given that mu, the universal set, is the set of all the days in a week, and B is a subset containing all the days in the week whose letters begin with S, then number 1, we are asked to find or list all the elements of mu. We are asked to list the members of B. We are asked to list the members of B prime or B complement. We are asked to obtain the cardinality of B and also obtain the cardinality of B prime. So let's begin. Now quickly, I'm going to start with a solution to this problem. So now let's see, if the universal set is the set of all the days in a week and B is the set of all the days in the week whose letters begin with S, then let us start with answering question 1. So for question 1, to list all the elements of mu means to list all the elements of this set. And how many days do we have in a week? We have 7 days, beginning with Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and of course, Sunday. So that answers the first question, which demands that we list all the elements of mu, the universal set. Now, number 2 demands that we list the elements or the members of B. Now, we are told that the set B contains all the days in the week whose elements begin with S. Now, what days of the week in the universal set do we find them having the elements beginning with S? You would notice that applies to Saturday and Sunday. That implies that B would contain as its elements Saturday and Sunday. So the 2 elements that will be in B are Saturday and Sunday, simply because they are the elements in the set, in the universal set, that begin with S, okay? Remember, B is the set of all days in a week whose letters begin with S. Okay, so now that answers question number 2. So to question number 3. In question number 3, we are asked to list the members of B complement. Now, what are the members of B complement? The members of B complement are those elements found in the universal set but not in B. Again, the members of B complement, also known as B prime, will be the elements you find in the universal set but not in B. Now look at the universal set clearly. You would find Monday, Tuesday, Wednesday, Thursday, and Friday. They are in the universal set but they are not found in B. So automatically, B complement, otherwise called B prime, would be the set containing Monday, Tuesday, Wednesday, Thursday, and Friday. So why does this set contain Monday, Tuesday, Wednesday, Thursday, and Friday? It is simply because B complement refers to the elements in the universal set that are not found in B. Okay, so let's move to number 4. For number 4, we are asked to find the cardinality of B. Remember, in our discussion on set theory, N in bracket capital B or uppercase B stands for the cardinality of B. And cardinality means set number, the number of elements in that set. So the question is, how many elements do you find in B? You will notice, let's count, 1, 2. So what it means is that the answer to that question is NB is equal to 2. Why is NB equal to 2? It is simply because the number of elements found in B tells its cardinality, represented with NB. Now, the next question, question number 5, for number 1 demands that we find the cardinality of B prime. Again, cardinality remains the same in its meaning. It means the number of elements found in the set. So how many elements do you find in B prime? You will notice that there are 1, 2, 3, 4, 5 elements in B prime. So all I'm going to write here is NB prime is equal to 5. Simply because the number of elements you find in B prime tells its cardinality, and represented with NB prime, that gives 5. Okay, so that answers question number 1. So let's move to question number 2. Now in question number 2, let's see, what are we asked to find? We are given mu, the universal set, as the set of all the months in the year. We are given A as the set of all the months in the year beginning with the letter J. And we are given B as the set of all the months in the year ending with the letter R. Okay, so we are asked to find the list, or we are asked to list all the members of the universal set, list all the members of A, list all the members of B, and then add the cardinality of A to the cardinality of B prime rather. So what we are going to do is to start with number 1. Now in number 1, we shall find or list all the elements of A. Now since A describes the months in the year, all the months in the year, or mu rather, so the universal set describes all the months in the year, so we shall list them. We have January, February, we have March, we have April, we have May, there's June, there's July, there's August, there is September, there is October, there is November, and then finally December. So these are the 12 months in a year. So listing these elements describes mu, the universal set. Okay, and that answers question number 1, since mu is the set of all elements or all the months in a year. Now for question number 2, all the months, A is the set of all the months in the year beginning with the letter J. So we are going to form the set A that contains all the elements in all the months in the year that are that begin with the letter J. Okay, so what months in this year, in this universal set, what months in the universal set begin with the letter J? They are July, June, and if you look around, you'll notice that there are no other elements beginning with the letter J. So it means that A will be the set containing as its elements June and July. Okay, now that answers question 2, where we're asked to list all the elements of A, or the members of A. So let's go to question number 3. Question number 3 demands that we list all the members of B. So what are the members of B? Remember, we are told that all the months in the year ending with the letter R would describe B. So let's see, what are the elements in the universal set that end with the letter R? You would notice September ends with R, October ends with R, November ends with R, and December ends with R. No other month apart from these months end with R. So quickly, I'm going to write out those months: September, October, November, and of course December. So these are the months that end with the letter R. Okay, now the next thing we shall do here, even though we were not asked, I'm going to quickly, because of the demand of question number 4, I'm going to form B complement. Okay, so what will B complement be? B complement will be the set that contains every element you find in the universal set but not in B. So what I'm going to do here is to write out all those elements. So what elements do you find in the universal set that are not in B? You will notice the elements are January, February, March, April, May, June, July, August. So together they make all the months in the universal set that are not found in B. Remember, in B we find September there, October, November, and December. But the elements January, February, March, April, May, June, July, August are not found in B. So they make the set B complement. Now, that brings me to question number 4. In question number 4, we are asked to add the cardinality of A to the cardinality of B complement. So the question is, what is the cardinality of A? The cardinality of A, if you remember vividly, the cardinality means the number of elements in the set. So the cardinality of A would mean, counting the elements in A, how many elements do you have in A? 1, 2. So the cardinality of A will be 2. Likewise, the cardinality of B prime will be NB prime, and that will contain how many elements? In B prime, we have 1, 2, 3, 4, 5, 6, 7, 8 elements. So it means B prime will contain 8 elements, and we can now get our result. So NA plus NB complement, which is demanded by the question number 4, will give us 2 plus 8, and the result will be 10. And that concludes question number 2. Okay? Now, let's move over to question number 3. In question number 3, let's see what are we required to do. Now, question number 3 says, if the universal set is the set of all countries in the ECOWAS sub-region, and X is the set of all Anglophone countries in the West African sub-region, Y is the set of all Francophone countries in West African sub-region, then let's list 1, 2, 3, 4. That is, number 1, list all the elements in mu. Number 2, list all the elements in X. Number 3, list all the elements in Y. Okay? So we may not be accurate with our description of the ECOWAS countries, but take note, the emphasis in this case is solving the problem. So the idea behind the problem is what I want you to take note, just in case we miss out on any of the countries in the ECOWAS region. But I believe there are 15 countries in the ECOWAS region. We may not be precise or may not be accurate with knowing which ones are Anglophone or which ones are Francophone countries, but we'll try our best, okay? But the essence of this question is to show you how to solve the problem, okay? So we must not lose sight of this. Now, let's start. So, in the ECOWAS sub-region, the economic community of West African states, now let's see, we have number 1, to list the elements of the universal set requires we write out all the countries. I think in the ECOWAS sub-region we have Benin, we have Burkina Faso, we have Cape Verde, we have Côte d'Ivoire, we have the Gambia, okay, we have Ghana, we have Guinea-Bissau, we have Liberia, we have Guinea, we have Liberia, there is Mali, there is Niger, there is Nigeria, there is Senegal, there is Sierra Leone, there is Togo. Okay, so let's count. I believe I'm right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so let's see. Benin, Burkina Faso, Cape Verde, Côte d'Ivoire, the Gambia, Ghana, Guinea-Bissau, Liberia, Guinea. We have okay, sorry, so I wrote Liberia twice, so I'm going to cancel Liberia off. So we have 15 countries in the ECOWAS sub-region. Okay, so let's see. Now that concludes question number 1, where we had to list all the elements in mu, and by that, of course, it means listing out all the elements or the countries in the ECOWAS sub-region. Now let's see, for question number 2, X, we are asked to identify the Anglophone countries in West Africa. So let's see. So Anglophone countries are the English-speaking countries, of which Benin is not among. Burkina Faso, I think, Cape Verde, Côte d'Ivoire is a Francophone country. Burkina Faso should be English-speaking. Okay. Now, if I'm wrong, please, of course, don't lose sight of what we are describing. So I'm going to put Burkina Faso to the best of my knowledge, okay, as an Anglophone. Cape Verde, I'm going to put as an Anglophone country. I know for sure that Benin and then Côte d'Ivoire are French-speaking countries. The Gambia, I'm going to put the Gambia as Anglophone. So I'm going to put Ghana as Anglophone. Guinea-Bissau, Liberia, I'm going to put Guinea. I'm going to put Mali is Francophone. Niger, do they speak French or English? Okay, let's see. I'm just going to put Niger there. I'm not sure, but I'm going to put Nigeria, certainly is Anglophone. Senegal, no. Sierra Leone is there, Anglophone. And then Togo, well, I'm going to put them as Anglophone, okay? Now, what I'm doing here is not exact, but take note, the essence is being able to list out the elements of X. So let's assume I'm correct, okay? So Burkina Faso, Cape Verde, the Gambia, Ghana, Guinea-Bissau, Liberia, Guinea, Niger, Nigeria, Sierra Leone, and Togo. Now, what it means is, if these are the Anglophone-speaking countries, then the Francophone-speaking countries will make the set Y. So, if the countries in the West African region, sub-region, are either Anglophone or Francophone, then all it means is that Y will be X complement, because Y will contain all the elements in the universal set that are not contained in X. So, what it simply means is that adding all the Anglophone countries to the Francophone countries will make the set, the mu, that is the universal set. Because Anglophone, if you're in West African sub-region, it is either you are an Anglophone country, that is an English-speaking country, or you're a Francophone country, a French-speaking country, okay? So I'm going to put here all the elements we did not put in X from the universal set. So which one did we not put? We did not put Benin. Burkina Faso is there. Cape Verde. Côte d'Ivoire we did not put. So I'm going to bring Côte d'Ivoire here. Okay. The next I'm going to put is the Gambia is here. Ghana, Guinea-Bissau, and Liberia, Guinea. So I'm going to bring Mali here. Niger. I think Niger should be a French-speaking country, but never mind. You can correct that. Okay. I'm going to bring Senegal. So these are the Francophone-speaking countries, to the best of my knowledge, of course. So you have to pardon me. Okay. So now IV. In IV, we are asked to find the cardinality of X plus the cardinality of Y. So how many countries do you have in X? The number of countries you have in X will make the cardinality of X. Okay, so what's the cardinality of X? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in my own description of the Anglophone countries, there are 11 elements in X. So I'm going to write here 11 for the cardinality of X. Then how many do you have in the Francophone speaking countries? We have 4 by my own description, of course, and that gives us 4. So notice that 11 plus 4 gives 15, which makes the universal set number, the cardinality of the universal set. So there are 15 West African states, and partitioned into 2, Anglophone, Francophone. You will notice that the number of Francophone countries plus the number of Anglophone countries will give you the number of countries in the West African sub-region, and that solves problem number 3. So quickly, let's move to question number 4. Now, what are we asked to do in question number 4? Given that the universal set contains A, B, C, D, E, F, G, H, K, L, P, Q, and B is a subset of mu, the universal set B, E, G, K, P, and L is also another subset containing A, B, D, G, K, P. So let's see, what will N mu be? That's the cardinality of the universal set. So what do we have? Let's see. Now, N mu will be the number of elements you have in the universal set. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that was simple. We will write 12, representing the number of elements we have in the universal set. So question number 2, under 4, demands that we find the cardinality of B plus the cardinality of L prime. So I'm going to write here cardinality of B plus cardinality of L prime, being what we are asked to look for. So I'm going to put a question mark here because we don't know what it is yet. But let's start with obtaining the set B, the cardinality of B. So the cardinality of B will be, let's count, 1, 2, 3, 4, 5. There are 5 elements in B, so the cardinality of B will be 5. Now, for us to obtain the cardinality of L prime, we have to find, there are 2 ways to go about it, but let's start with obtaining L complement. So L complement or L prime will be the set of elements found in the universal set but not in L. So in L we have A, B, D, G, K, P. So what elements do you find in the universal set that are not found in L? Let's list them out. So there is A in L, in the universal set there is A, B, B. So I'm going to bring out C. So C is not found in L, but it's found in the universal set. E is not found in L, but it's found in the universal set. F is not found in L, but is found in the universal set. G is found in both. K is found in both, but H is not, so I'm going to bring out H. P is found in both. So what do we have? We have L and I think Q. So now, how many elements do you have in the universal set? 12. How many do you have in L? 1, 2, 3, 4, 5, 6. So there are 6 elements in L and also 6 elements in L complement. So it means that NL complement will be 6. So that brings us to NB plus NL complement will be equal to 5 plus 6, and that gives us 11. So why? Let's go over it again. Now in B we have 5 elements. Remember, the cardinality of B is you counting 1, 2, 3, 4, 5 elements of B. Now we were not asked for the cardinality of L, so we cannot be counting L. Rather, we were asked to find the cardinality of L complement or L prime, and L prime would contain elements in the universal set not found in L. So that was how we obtained C, E, F, H, L, and G. So, and Q rather. All we had to do was to obtain the elements in L in the universal set not found in L. So that gave us C, E, F, H, L, and Q. Now obtaining the cardinality of L complement was to count the 6 elements in L complement. Okay, And adding the cardinality of B to the cardinality of L gave 5 plus 6, which is 11. Now let us go to question number 3. So in question number 3, we will start with obtaining B prime, okay? So what is the set B prime? The set B prime contains all the elements in B in the universal set not found in B. So what are those elements you find in the universal set but not in B? Let's see. So in the universal set we have A, and A is not found in B. So I'm going to write that here. A is found in the universal set but not in B. So again, in the universal set there is C and it is not found in B. So I'm going to bring that here. C is found in the universal set but not in B. In the universal set we have D and it is not found in B. I'm going to write that here. In the universal set we have E and it is also found in B, so we skip that one. We have G, which is also found both ways. We have F but not found in B, so I'm going to write F here. We have G found in both, K is found in both, but H is not, so I'm going to bring H here. Okay, then we have P found in both, but we don't have L and we don't have Q. So we have A, C, D, F, H, L, and Q as elements you find in the universal set but not in B. That implies that N B prime, the cardinality of B prime, would give us 1, 2, 3, 4, 5, 6, 7. So I'm going to write here 7. There are 7 elements in B prime. Okay. Now let's see. What are we asked to do? We are asked to find N B prime plus NL. Now what is NB prime? We've just obtained it to be 7. Added to NL, the cardinality of L. What's the cardinality of L? How many elements do you have in L? 1, 2, 3, 4, 5, 6. So I'm going to write here 6, and that gives me 13 altogether. Okay. Now the last question demands that we find, as question number 4, we obtain NB prime minus NL prime. So that will be equal to what? NB prime, remember we got NB prime to be 7. So I'm going to bring 7 over here. Minus NL prime, remember we obtained it to be 6. So I'm going to write 6 here. And that will be 7 minus 6, which gives us 1. And that answers question number 4. Now, let's move to the last question we shall be solving in this video. Okay? Now, remember this is our solver series on set theory part 1. So, watch the video over and over again. It will teach you how to solve problems like this. Okay, so let's go to the solution to this problem. Okay? Now, we are given the universal set mu as a set of all positive integers less than or equal to 30. So the set of all positive integers less than or equal to 30. Now I'm going to write mu here for number 1. We are asked to find n mu. So I'm going to put a question mark here. For now, we don't know what that is. But let's start with obtaining the universal set. So we are told the universal set contains all the positive integers less than or equal to 30. So let us list out all the positive integers less than or equal to 30. So all the positive integers less than or equal to 30 would contain 1, 2, 3 to 30. Okay, because 30 is actually included in that list. So all the positive integers less than or equal to 30 would make the universal set. So that implies that n mu will be equal to, from 1 to 30, you would have 30. Okay, so you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So from 1 to 30, you have 30 elements, okay? And that makes our cardinality 30. Now, let's go to number 2. In number 2, we are asked to find the cardinality of n. So let's see. I'm going to put a question mark also there, and let's go to the elements of n. So what elements are found in n? Now look at it very well. We are told that n contains all odd numbers less than or equal to 9 or equal to 19. All the odd numbers less than or equal to 19 extracted from the universal set. Okay, so let's extract from the universal set all the odd numbers less than or equal to 19. Less than or equal to 19 means 19 is included, okay? So from the universal set 1 to 30, let us extract all the odd numbers less than or equal to 19. So I'm going to pick 1, 3, 5, 7, 9, 11, 13, 15, 17, and then 19. So these are all the odd numbers less than or equal to 19, and that makes the set n, okay? Now, what are we asked to find? We are asked to find the cardinality of n. That implies that the cardinality of n will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So why is it 10? It is simply because cardinality means the number of elements in a set, or the set number, and there are 10 elements in this set n, so the cardinality required is 10, okay? Let's go to question number 3. Now for question number 3, we are asked to find nn plus ns. Okay, I'm going to put a question mark also there. Now, we've already obtained nn, and that is 10, okay? But we have to look for ns. So here, I'm going to start with obtaining ns. For now, we don't know, okay? So let's come over here. Now, but you know, S will be the set as described here, all integers, the set of all integers, x, such that x lies between 10 and 30, with 10 and 30 inclusive, okay? All integers, so I'm going to start counting from 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and then of course 30. Okay, so that is the set n. Again, S is the set of all integers x, such that x lies between 10 and 30. Now, I would want you to watch our video on set builder notation, the first video on set theory. You will find that there, how to read, or the second video rather. It will teach you how to read set theoretic notations and also to interpret them. So let us see now, how many elements do you have in S? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So there are 21 elements in S. Now, having obtained ns, we are now going to add nn to ns, and that will be adding what we had in nn is 10, or for nn, that is 10, and what we've had here is 21. So adding both together gives us 31, and that solves that problem. Now, let's go over to question number 4. So for question number 4, we are asked to find nm complement plus ns complement. So I'm going to put a question mark again, because we have to obtain, first of all, we have to obtain m. Now, what are we told about m? M is the set of all even positive numbers less than or equal to 20 from the universal set. All even positive numbers less than or equal to 20. So let's see. If you select all the even positive numbers less than or equal to 20, you would have 1, or you have 2, sorry, because 1 is not even. You have 4, 6, 8, 10, 12, 14, 16, 18, and of course 20, because we were told less than or equal to 20. So listing out all the positive even numbers from the universal set less than or equal to 20 gives us this set, and that implies that M prime will be the set containing all the numbers that are not found in M but found in the universal set. So let us list out that set: 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, then 22, 23, 24, 25, 26, 27, 28, 29, and then 30. Now what am I doing? I'm simply listing out all the elements that are found in the universal set but not in M to get M prime. Okay, now I'm going to continue this problem over here. Let us quickly look at what about S prime. So we are going to start with obtaining S. S would give us the set. Remember, we obtained S as above. We obtained S to be this set here. We had obtained S to be this set containing 21 members. Okay, so NS we had already obtained to be 21. Okay, now what will be the complement of S? The complement of S would contain elements of the universal set. So S prime would be elements of the universal set not found in S. Okay, now one way to do that is just to subtract the cardinality of S. If you want to get the cardinality of S prime, all you have to do is to subtract the cardinality of S from the cardinality of the universal set. That will give you 30 minus 21, which gives you 9. So this is a very fast way to get that done, but for teaching's sake, I would want you to know how S complement is formed. Okay, so S complement will contain all the members of the universal set not found in S. So what members of the universal set do you not find in S? You will notice that there are 9 of them. So you would have for that set you would have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the elements of S complement, and that is why we have them in cardinality to be 9. Okay, so now that being said, let us now obtain our result for number 4. NM complement plus NS complement will now give us, we obtained NM complement to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'm going to write here 20 plus NS complement. So we have NM complement to be 20. NS complement would give you 9. And together it adds to give us 29. Okay? Then finally, to wrap up our solver series video part 1 on set theory, let's look at question number 5. So question number 5 requires that we find NM plus NN. So that is simple. We've already obtained NM to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that will be 10 plus NN. NN, we obtained NN to be 10. So this will be 10 plus 10, giving us 20. Okay, so you go over all we have solved in this video, and I'll see you in our part 2 video on the solver series on set theory. Like our video, please watch our video to get enlightened on how to solve problems on set theory. and most importantly, subscribe to our YouTube channel, as you would help us grow our channel. Thank you very much.